Hello, this is the first step of the 3 steps to crack calculus. This calculus, I heard many high school students said it's hard. I don't understand. Okay, I think most of the reason is they skip this step 1. I show you what is important before you learn the calculus, what's important to know. And this, once you know this, the step 2, step 3 is very smooth transition into calculus. Okay, so what is missing in the high school math textbook? The calculus is nothing but just one new type of number. Okay, so you learn so far the number, integer, and ratio of integer, which is rational number, right? Whatever. And also you learn irrational number, like square root of 2 here, or pi. Okay, so that's all real number. And you didn't learn anything over real number. Maybe you learn vector matrix and stuff, but the real number is basic number you learn. They somehow, high school, they don't teach there is one more type of real number. Okay, for example, you look at close to 1, very close to 1. Okay, 1 plus x squared plus x. You learn this series, right? When x goes to 0, this goes to 0 means you just get close, infinitely close to 0. Then is this 1? No, it's larger than 1. Okay, it's on the plus side. So if you move this one here, 1 plus minus 1, larger than 1, 0. So this is clearly different quantity. Okay, this can define the new number. It's, well, we can use this x goes to 0, or let me 1 plus. If this guy is negative, it may be 1 minus, the minus side here. Okay, so there is a number that is different from 1, but it's extremely close to 1. Extremely close. What do you mean extremely close? Okay, no matter how close number you quote, it's still closer to 1. Okay, so this difference is called, it's so small you cannot specify. It's called infinitesimally small number. Okay, and you know, this kind of number is in mathematics, epsilon delta logic. It's precisely defined, but we don't have to worry about this one here. In the high school math, we just need to understand there is a possibility that we can define a number called infinitesimally small number. So 1 plus is 1 plus some kind of number which is larger than 1, and definitely it's not 1. There is some quantity, but it's just small. Epsilon, we write it this way. Okay, so now you see every number, every real number, like 3, on the both sides there are number 3 plus and 3 minus, right? And this number is something like when you boy and girl play game. Okay, you tell me largest number in the universe. So then I will beat it. Okay, then boy tell very big number. Then girl said, okay, +1. It's larger. Okay, epsilon delta logic is something like that. Okay, so this is the same way. You tell me what is the closest number to 1. 1.0000001. Well, I give you closer one. 0.1. Okay, so I can always tell you the closer number to 1. So that's the number. And this is another real number which you didn't learn in school. Okay, so is this only one number like that on the right side of 1 and left side of 1 there's only one number? Not really. If you think about it, 1 plus x squared plus x4, you skip this guy, then this will be 1 plus, this will be also 1 plus, but this second 1 plus definitely is smaller than 1 plus, right? Because we skip these. There are some quantity, extra quantity this guy has. So that means this guy is a little bit larger. So if you look at number line, say -1, there is a -1 plus, maybe another -1 plus, maybe how many? Well, actually infinite number of this kind of number, which is called unspecified number, the number plus infinitesimally small number. Okay, or number minus, this guy is number minus infinitesimally small number. So that's also real number. You haven't learned this in school. Okay, you have to learn about this number first before you learn calculus. Okay, so what happened if 1 plus infinitesimally small number is larger than another 1 infinitesimally small number, or could be 2, right? If you subtract, then this is gonna be some kind of infinitesimally small number again. It's almost 0, 0 plus or minus, right? If you add, what's happened? Then it's gonna be probably 4 plus. So it's kind of boring to do as subtract of those number, okay? But it's get very interesting when you take the ratio of two infinitesimally small number. Say, let's take this example. Okay, now -2. This gives epsilon 1, and 2, 1 minus 1. This gives some kind of epsilon 2. Okay, then what's happened to this ratio? Okay, this ratio can be 0 or some kind of real number, or maybe infinite. There are many cases. Okay, so this ratio is what we are interested in here. How you get the ratio? We learned a function, okay, and the function can be something like that. You remember this white circle means excluding this point. Okay, so in this function, x equals 1 will be 1. Okay, now if you use this kind of number 1 positive, okay, then y is, you come from here positive, getting closer to closer, y is 2. Okay, actually 2 plus, right? Very close. 2 is not included. If you come from other side, from here, then it's gonna be 0, negative, right? So depend on what you put in the function, even it's getting close to 1, it's different from putting x equals 1. This happens in discontinuous function. If function is continuous, like it's never happened. Okay, there is always this, and this value agree. Okay, so for example, you take 1, and if you say, I give you one real number, now we say this is also real number. This we just simply write this way. What is this real number? f1 plus. Well, it's going to be 1 plus, right? Y equals f, negative side will come from this side, then it's gonna be 1 negative. Okay, so we always have this for this real number. Okay, so when we define the, we want to know what number is going to be, like y, y equals f 2 plus. When you put the 2 plus, it's going to be 4 plus, right? But we want to know this number. We say limit x goes to 2, you plus 2, right? But the limit is only this part. Which number? The number is going to be larger by infinitesimal quantity. That's what the limit means. Okay, so we have this. So let's get back to the ratio. I say that's get very interesting. Say if you have 1 and plus epsilon, right? That's 1 plus. Okay, so that's gonna give f1 plus. Okay, so we take 1 plus epsilon here, so it's gonna be 1 plus epsilon, right? Okay, so what we get is 1 plus epsilon square minus this is 1, and 1 plus epsilon minus 1, so that's disappear, right? So this is gonna be 1 plus 2 epsilon plus epsilon square minus 1, and the 1 disappear and epsilon stays, so it's going to be 2 plus epsilon. Now we make epsilon very small, infinitesimally small. This is going to be 2 plus, right? And if you take a limit, it's 2. So limit of this ratio is going to be 2. Okay, so what does it mean? What it means is we take little amount and we took little amount, and this ratio is like a tangent, right? At the x equals 1. This tangent we calculated, it's going to be 2. And tangent is slope, right? So that means we can calculate the slope of the curve at this point. Okay, so only x equals 1 is no fun. Let's make it at x point, x plus, we take a small amount, okay? And this is going to be infinitesimal number. And infinitesimal number, this side is x plus epsilon minus x. That's disappear, okay? So x squared plus 2 epsilon x plus epsilon square minus x square, and that's disappear, and epsilon, so that's disappear, so 2x plus epsilon. So when epsilon goes to 0, this goes to 2x plus, right? And if you take a limit, then answer is 2x. And what does it mean? You take any x, we can now calculate the tangent. Tangent is simply 2x. If x is 3, then tangent is 6, right? If x is 4, then tangent is 8. Okay, the tangent is a slope. So now there is a very good use of this infinitesimally small number. We just take infinitesimally small number, x plus epsilon minus fx, and take the ratio. And limit gives you tangent at x. That's useful because it was hard to calculate the tangent of any curve. Now we have a way to calculate the tangent. So that means, let's see, when you have a y equals fx curve like that, if this is x squared, the tangent become 2x. That means you take x1, this tangent is 2. If you take 2, this tangent is 4. Okay, and this tangent function at x is called derivative. Here you go. So we already know what the derivative is. So we can write f and g, or we can invent some notation. Let's say, what is the derivative function of f prime, which is gx? Same thing. Okay, how about we use a fancy notation? What the derivative function of this? This again gx. Okay, now when you get the tangent, you have this and this. We call this dx, dy. Then we can say, hey, dy dx ratio is going to give a tangent, which is gx. Okay, that's what all derivative is about. So it's all come from infinitesimally small number. Once you understand infinitesimally small number, then we have a one useful way to calculate the tangent of the function. Okay, that's the end of step 1. Please move to step 2 video.